Okay, so first of all, let's just start. Uh, Again, this is an introduction class. I mean, we're talking about everything a little bit. It won't go very deep. Okay, it won't go very deep. So this is the so first let's talk about some vocabulary, the concept first. Okay, so in physical science, we're talking about object. We talk about object. So object usually is just everything that you observe. Okay, for example, I try to measure the table, and the table gonna be the object. Okay, I try to looking at I mean what inside your body, and your body will be the object. Okay, so the pretty straightforward. And if we want to looking at the sun will be the object. Looking at the moon will be the object. Okay, so the object, the concept is pretty straightforward. Okay, yeah, and the people always try to describe. Okay, so sometimes you need to describe an object, right? And then you're going to using the different vocabulary to say the object. Here is that, okay, we have a high chair. That means the chair is really high, right? And or a lot of people using the color, okay, they try to talk about the concept. You see, another concept is here. To learn to form a generalized mental image of the object is called a concept. So concept is a mental image of the object. Okay, generalized mental image of the object is called a concept. So concept of the if you give you the concept object, so it give you an idea. What is that? This is easier for people to communicate with, right? Yeah. So last week, I eat a very delicious food. Then the other people said, okay, what kind of food? I forgot it. Then we're stopped the communication, right? Yeah. So you need to using some words to describe, okay? It's a salty food or what style this food? Italian food, Mexican food, Asian food, Vietnamese food, Chinese food, and then the people will have some idea. Okay, narrow down the category you're talking about, and then you can go further for the communication. That makes sense, right? Yeah. Yeah. So this is a concept, and people usually to try to using the concept to describe things, to describe the things. So another concept is okay. You want to okay. So when we describe some of the object, again, you're going to have some of the property you need to characterize, right? You need to say this is a sweet, or this is like a salty, it's a crunchy, it's a smooth. So all of the words actually is try to describe the property of those of this object. That makes sense, right? The property of those objects. So the definition of here is the property. And what is the property? And generally is quantity or the attributes that are usually equal to an object. Okay, maybe it's a color, it's a texture, and the size. So those are the property. And in the future, we probably also going to talk about like a physical property and chemical property, but generally the property is some of the attributes or the quality of the object. Okay, so that is the property. Okay, that is the property. Okay, so that is the property that we talk about. But the point is, okay, so when the people talk about the property, they would like to using some of the what we call here the words, the reference. They're giving you some of the reference to give you some idea what is that. For example, we give you an example about, okay, we talk about the blue is so clean and so bright and so blue. What a blue sky is. And then you give your idea, okay, what is the color of the sky? Talk about the orange. Okay, then you have your image, your mind, you know what is the color it is, okay? Or banana yellow, okay? Or lime yellow, or lime green, okay? So we generally have an idea, what is the color of this, okay? So all those words, and we call it as a reference over here. When you give here some of the reference, then you know what is that. What we talk about, in this object, for example, okay, what do you think? What's the height of this bottle? And about maybe a little bit more, 12 meters. So inch over here is the reference, because you know this is about 1 inch, right? So when you're talking about everything, generally you're introduced a reference. Otherwise, how come people can? So that's why sometimes it's hard to communicate if two of you have no common reference. Then that's gonna be hard. That makes sense, right? So if you're introduced a reference and other people understand, easy to understand. That's it. Okay. So those are things is what we call a reference, because you're introduced some of this. Okay. But the point is, okay, if you're just using the verbal things, sometimes it's not a very easy to specify some of the property of the property of this the object. Maybe we're talking about, okay, some people the same day, maybe told them says, it's not that cold. Today we're not cold, it's not cold. Or some people, I'm saying it's really cold here, right? Well, I mean, how cold is cold? How hot? Hot. Okay? I mean, different people have a different reference. Okay, this is the comparison of difference. That is difference, right? If you're talking about the people living in the Houston, we're not too hot out here. But I'm from Wisconsin. I mean, I went to the hill Houston. I feel there's so moisture and hot. And so the different people. So that's why if you're just using the vocabulary to describe a property, sometimes it may not be exactly true, and different people will have a different idea. Okay, so that is why. Science. We need to make sure everyone understands the same thing, right? So that's why we're going to use quantitative problem. We're going to introduce some numbers, right? Everything is a variable. For example, the weather. Today is not too hot, okay, but it's 40 Celsius, or it's 110. What do you think? Is it high? Is it too high? Or is it not as cold? Okay, so if you give your those numbers on there, then it helps you to understand what exactly is the fact, right? The fact is a difference, the concept. Different people compared to the same thing, the feeling is different. But the fact will be. That's right. So this is why this is how the science talking about. Okay. So this is why we need to quantifying the properties. Okay, we need to have something to measure it, to quantify the property. So that's why, first of all, in science, we need to measure things. The things should be measurable. If something is not measurable, then we cannot using the scientific method to work on this. That makes sense, right? Yeah, because if you just talk about feeling, different people have a different feeling. We have to collect some of things that everyone think this is true. Then we're doing the study, doing the scientific study. That makes sense, right? Yeah. So measuring things is very important. And again, when you measure things, we need to using some of the reference. Again, we talk about then as a unit, like an inch. 1 inch is about this. And you talk about the reference, centimeter is about that long. Okay, so reference is also very important, and this is the unit. With the number and the reference or the units, generally you can compare things. That makes sense, right? You can compare things. Okay, so comparing in general science. What is science? Science typically it just try to doing the comparison and making a conclusion. This is what happens for the science. Okay, yeah, we're doing the comparison and we make a conclusion. Okay, yeah. So this is the importance of the measuring things and the measuring the properties in science. Okay, so that's why when you talk about some of the things, you give it a number. Meanwhile, you need to give a unit, right? Yeah. We're talking about this. I mean, this bottle can hold 100. People said 100 watt. Maybe, or maybe ounces. Okay, well, maybe 100 ounces. Okay. Generally, so you see the unit give you the idea what exactly. Okay, so when we talk about science, very important thing is we need to know the unit. Okay, you need to give a number. Meanwhile, you're gonna give a unit. This is a very most important part. Okay, yeah. So that's why when we talk about in the lab, when you do the calculation, please write a number and also the unit. Okay, the unit is very important. Okay, yeah, unit is very important. Does it make sense now? Okay, yeah. Okay, so now we already talked a little bit about the measurement system, so we can talk about a little bit more about the system. Okay, we're going to have a different unit. For example, so here is give you the example over here. We're having the distance. We talk about the distance of the 2 points. Okay, we have a lot of those units over here. Okay, and then which one? Okay, what do you think? Which one could be a standard unit? I mean, what's the common unit we're using over here? We're using miles over here, right? Although all those are the units, distance, but 100 miles over here is the units we're commonly use. So that's why this is called a standard unit. Okay, it's called a standard unit. In other words, it's people commonly use is called a standard units. So that you can see the definition over here. The standard unit is the measurement unit established as the standard upon which the value of the other reference is of the same type as outdates. Okay, so generally the standard unit is the common unit that people use. Okay, yeah. So that's a standard unit that the people commonly use. We're using mile instead of the other stuff. Okay, so and I think you already know it. Generally, we have two different systems. We have the English system and a metric system. You know which country using English system? The only US, right? The only US. Well, even the British not using the English system. They're still using, I think they're still using pound, but most of it they're going to using kilogram. instead of pound as a weight, okay, to measure the weight. Okay, so majorly we have English and metric. I think the rest of the other world except the US, we're not talking about English anymore. They said only just a metric system in the world. Well, anyway, you have any idea why? I mean, since every other country, the English is using the metric system, why the US is still going to using the English system?
It's English, therefore, that's English.
No. Think about the cost. Think about the cost. Right now, if you go to the grocery store, everything measured in pound. If you want to change that to kilogram, how much expense they are going to additional pay if you spend for the changing the system, and how much knowledge everyone needs to understand. Again, we talk about the reference. So just the changing the unit is not just changing a unit. Everyone needs to leave this world, or everyone in this country should be agree. We understand what is a kilogram, how much kilogram it is, right? In another word, we need to educate everyone. And so everyone agree this unit we're going to use. Then, right, because the reference is very important. So that is why. Okay, so if you just suddenly change that units, that's very, very costly. That's why. Okay, so maybe like 20 years later, we can convert that back to the metric system, but definitely it's not right now. Okay, what it says is the parts that we consider. Okay. So metric and the English system, and here you see, here this is a very interesting things. Okay, metric system actually, or the English system actually is coming. We borrow some of the idea from the previous the Greek and the Roman system, the measurement system. Okay, for example, the one thing is about this one. Okay, everyone has a difference, but generally it's about this size. Okay, the first joint to the end of the dot. So this is about 1 inch. Okay, yeah. So we talk about yard. The hands from this end to your nose. This is about the yard. Okay, 1 yard. Well, different people will be different. Okay, so that's why. But if you open that straightaway, that's called the phantom. That's also a unit. Okay, yeah. And then we talk about foot. It's about the foot of this. Okay, and here it says 1 mile. Okay, what then? 1 mile. 1,000 double pace is 1 mile. Okay? So this is where the mile is and the inch comes out. That means interesting, right? It's pretty interesting when I see this. Okay, so here, let's focus on the metric system. Okay, let's focus on the metric system. Okay, those are the units probably recognize, because those are the basic units. Basic units. There are only 7 basic units. Those are the 7 basic units. Okay. The SI, that's this is the international system. This is the SI is a national system. I have no idea why it's SI instead of IS, but generally this is international system. Okay, so there are 7 different units. Those are here. They have a length, mass, time, electric current, temperature, amount of the substance, and the luminous intensity. Okay, so those are basic 7 different units. Most common units we're using is 4 of them. I think we have a length, mass, time, and a temperature. Okay, mass, length, mass, length, time, and a temperature. Those are 4 basic common units that we're using. But in chemistry, we have one more thing that I'll majorly talk about in chemistry. Amount of the substance is we're also using the mole. So those are the 7 units. This is a basic unit, which means a lot of the units is coming from a lot of other units is coming from this. Okay, it's coming from this. For example, if we talk about the volume, right? Volume is actually coming from the length. It's volume is the length times wide times height. Okay, so there are 3 of those that come together, then you got volume. So volume is derived from the length. Okay. Or talk about density. Density is a mass over volume. So density is also derived from the length and the mass. Okay. So this is those 7 are the basic units that we're talking about. Any questions? No? Okay. Yeah. Okay, so now we're going to talk about some of the detail about the standard units for the metric system. Okay, standard units of the metric system. And here the basically is a length. We already talked about the length. Generally is in the metric system, the length we're using a meter. Okay, we're using meter. Area is just the length times length. Okay, so that's why you have a square, meter square. Okay, the unit for the length for the area, that's a meter square. And for the volume, it's just a length times width times height. It's just a meter times meter times meter. So you got a meter cube. Okay, so that's the difference between those 2. Yeah, length we're using meter. Okay, we're using meter. Okay, so here it said the meter actually is defined as the distance of the light traveled in a vacuum during a certain time period. And this time period is this. Well, don't ask me why we have this time period, but generally this is how we define the meter. Okay, this is how we define the meter. For the math, we're using the kilometer. We will talk about the kilo mean later, but the kilogram is the mass we're going to using instead of using gram, kilogram. Okay. Time basically is pretty common. It's just a seconds. The basic unit is seconds, and we know meter and we know hour. That's it, right? Meter and hour. Okay, so 60 seconds is 1 meter, 60 meter is one hour, and 24 hours is 1 day. Okay, so those are the fundamental units that we're talking about. I think here is going to talk about the metric prefix. Okay, so this is the major part that I would like to talk about. Okay, very important. But this is also the beauty part of the metric system. Okay. This is the beauty part of the metric system. So in the metric system, we have a prefix. Usually, we're just using the prefix plus a certain unit. Okay, you can use the prefix plus any of the units, right? We talk about the 7 different units. You have a meter, then the gram, and we have time, seconds, and we also mass. What else? Mass, time, temperature. Okay, the temperature, but not. So you can use the prefix plus any of the units altogether. Then you can, the temperature here is using the Kelvin. Okay, yeah. So but the prefix is pretty interesting. This is the beauty part of the metric system because they always increase by 10 or increase by 100 or 1,000. Okay, so that is the beauty of the prefix. Okay, yeah. So those are prefix. I don't want you to write remember all of those. That's too much. Okay, that's too much for the prefix. You don't have to remember this. You don't have to remember that. But those are probably start from here. You're gonna remember. So tera means trillion, which is 10 to the 12. Okay, where did you hear the terabytes? Okay, talk about size of the storage room, storage for your computer, terabytes. Okay, so the sum of computer has a 1T, 2T, and that's T is tera. Okay, terabytes. Okay, yeah. So giga, I done generally also coming from the gigabyte, right? And also we hear about megabytes, right? So gigabytes, megabytes, this is talk about a billion and a million. Billion is 10 to the 9th, and the million is 10 to the 6th. So those are all the prefix that you can add in front of the unit, right? So if you're talking about, we have a T amp, capital T, remember, I see capital T, T amp, that means a terameter, which means 1 terameter, and you just replace the tera to the number that you have. 1T is equal to 10 to the 12. So 1 TM terameter is just 1 times 10 to the 12 meter. You see, this is a pretty straightforward to replace because the T is just equal to 10 to the 12. So this is how we convert this to each other. That makes sense, right? Okay. So if we have a 1 GM, this is a gigameter. Gigameter is a 10 to the 9th meter. It's just a 1. You replace the G to the 10 to the 9th times 10 to the 9th meter. And then it gives your 1 times 10 to the 9th meter. Make sense? Ten to the 12th. G equal to the 10 to the 9th, right? So G actually means billion. Okay. So if you have a 1, the next part is mega. So if you have, this is a capital M, remember, you see, the symbol over here is capital M. So if a capital M, small m, that means a megameter. If you have a megameter, then just a 1 times 10 to the 6, because M, capital M means 10 to the 6. So 1 megameter is equal to 1 times 10 to the 6 meter. Okay, so doing the conversion, it just you understand what is this prefix mean, and then you can just replace the prefix to a certain number that represent it. That's it. Okay, and then if we go down, then let's go to the kilo. Kilo actually means 1,000. Okay, kilo means 1,000. So if we talk about the K is a small k. Okay, so kilo, what does that mean? Kilo cow. Kilo cow. 1,000 cow. Okay, so the kilo just means 1,000. Okay, 1,000. So it doesn't matter what you add in later, it just means 1,000 something. Okay, that's the meaning of the kilo. So the kilo using small k, and then that means 1,000. Okay, so kilo cow, 1 kilo cow, and just equal to 1,000 cows. That's it. Okay, so kilo, 1 kilometer is just a 1,000 meter, which is also we write is a 10 to the 3rd meter. 1 times 10 to the 3rd meter. Are you clear? That makes sense? Okay, so this is the beauty of the prefix, because you can add any of the prefix for those basic units. That's it. Okay, yeah, it's not like the English system. You need to convert. Okay, 1 inch, how many inch to the inch to feet of 2 feet? What is the change? Right, but it doesn't mean one. How about the 60 yard? 1 yard equals to 2 feet, right? This is how we do the conversion. So you gotta remember all of those conversions. Okay, it's not calling on the 1 yard equals to 12 feet. 1 inch equals to 1 foot equals to 12 feet. Some of this right and some of not. How about yards and miles? No, not that. All right. So that's why we say the prefix is very. You just need to remember. Okay, what is that? The term, mega, kilo, but not so many people use that. The common is just kilos. Right? Kilo means 1,000. That's it. So another common, you don't have to remember this. Very, very, very small people using this one. Okay, yeah. Deca yearly, I'm not going to using this. I mean, very, very small people using the Deca. Some people using this. Deci, which means called 1/10, 1/10, but not that much. The commonly used centi. This is where the centimeter comes from. You see, centi is a cm because this number is a c, right? You can write a centimeter, or you can write a centigram, or you can write a centiseconds, right? Or even you write a centicelsius or centi K, Kelvin. But most commonly people using centimeter. Centi is equal to 10 to the -2, which is a 0.01. So that's why you see 1 centimeter. How do we know the centimeter equal to how many meter? Centi means 0.01. So 1 centimeter is just 1 times 10 to the -2 meter. which is equal to 0.01 meter. Okay, so what do? It just replace the prefix to a certain the number that refer to it. That's it. Okay, so so this why we can understand that part. Okay, and the most very common unit is this, is a milli. You heard of the millimeter? Have you heard of millimeter? Milligram. Have you heard of this? Milliliter, right? So milli, this is a very common, okay? So this is very common. This is also very common. The kilo and milli. So milligram, that means 10 to the negative 3, which is 0.001, means 0.001. So 1 millimeter is equal to 0.001 meter. Are you clear? Okay. So 1 millimeter equal to 0.001 meter. Again, you replace the milli to this number. That's it. Okay. Just replace the milli to this number. That's it. Because a milli means 0.001. Or 1 milligram is just equal to 0.001 gram. That's it. Okay, 1 milligram is equal to 0.001 gram. Okay, yeah. Micro and nano, I think some of you have heard of this before. Micro is talk about 1 millionth, which is 10 to the negative 6. So 1 micrometer, my 1 micrometer is 1 times 10 to the negative 6 millimeter. Okay, or you write like a 0.00001. Okay, so 1 and you have a 6 zeros in front. Okay, so this is a micrometer, and you know what is a micrometer? Anyone using powder? Using makeup, right? Okay. So the size of the makeup, when you touch the makeup, do you feel something? Do you feel something? Is it smooth? Very smooth, right? Yeah. So just to let you know, if you can feel something, I mean, when you're doing this, then that means the size of the particles of those makeup is larger than 2 microns. Okay? If your feel is not that very smooth, it's definitely smaller than 2 micrometers. Very small. Okay. And you can also think about the thickness of your hair. The thickness of the hair is about like a 1 micrometer. Very thin. Okay. It's about 1 micrometer. Okay. Or about less. And the size of the cell, size of the bacteria is about like a 1 to 2 micrometer. The bacteria is about a 1 to 2 micrometer in size. Very, very small. But it's still there. Okay, still there. For the nanometer, anyone hear the nanometer? Where did you hear the nanometer? 1 M. Where did you hear the nanometer? Technology, right? A lot of people find technology. This is a nanotechnology. Okay, nano this, nano that. So in general, nano technology. The reason we call it nanotechnology is because the material degenerates. It's about the nano size. And then the nano size is 10 to the 9. 1 billion. 1 billion. There's a 1 to the 10 to the 100 9. That's like the size. very, very small, very, very small. And sometimes in the nanotechnology, the nanosized particles, the behavior is different. Okay, so if you put the nano magnets, nano size magnets into the water, the behavior is just like a liquid, very smooth, just like a liquid. I think that there's some of the some if you go to the science museum, yeah, I saw a lot of different science museums, they always have this. They go to the different size of the magnets for water, and then we have the magnet bar for triangles. Okay, magnetic nano size of magnets is feel just like a liquid. So the one we move very smooth, just like a liquid. Okay. But if you have the bigger size of particles, you can see that's a solid. So that's why this is a behavior is different. That's very small. So that's why. Okay, you don't have to know the pickle. Don't have to the femtone and the endole. This is too small. Okay, it doesn't mean anything. Okay, yeah. But so the commonly, I hope you're gonna remember what is a kilo, what is a milli. Okay, those are very, very common units that people use. Okay, kilo, milli, micro, and a nano. Sometimes it's a centi, then that's it. Are you clear? Okay. So let's take a break. Okay, our class end at 11, right? 10:55. Okay, yeah, so let's take a break. Okay, then we will keep continuing. Probably it just take like the break. Usually this is how I do it, okay? We always put the over a lot of people like 2 minutes around.
And just like that.
That's okay, yeah, you can take a break. I mean, your mind needs to have a break.
Don't consider I read it, but don't worry, I read it happen.
Um, Okay, so let's come back. Okay, so now we're talking about the unit. And we talk about what is the common unit that we're using. Just like you know, I talk a little bit, focus the different things, like the textbook, but pretty similar. And then they also introduce some of the derived units. Okay, so this is here the story where we find the define the kilogram. Okay, so they're using centimeter, 10 centimeter by 10 centimeter by 10 centimeter, the volume of the water, then the weight, the mass of that much of water is defined for 1 kilogram. Okay, so 10 centimeter by 10 centimeter by 10 centimeter. So you can see 10 centimeter, 10 times 10 times 10, we have 1,000 cubic centimeter. So the 1,000 cubic centimeter weight for 1 kilogram. So this is by definition. 1,000 cubic centimeter is defined for 1 kilogram. Okay, 1 kilogram. So that's why the people can think about if you have like a 1 by 1 by 1 centimeter times 1 centimeter times 1 centimeter, then you will got 1 cubic centimeter. So 1 cubic centimeter should have like a 1 gram, because it's a 1 kilogram, 1,000 square cube. Let me just write over here. By definition, they said 1,000 cubic centimeter, the mass should be equal to 1 kilogram. And again, you know the kilogram, kilo means 1,000. So 1 kilogram is 1,000 gram. So 1,000 cubic centimeter, the mass equal to 1,000 gram. So that's why if you have a 1 cubic centimeter, that's give you 1 gram. Sorry, this is not a conversion. The mass of the 1 centimeter of water, that should be equal to 1 gram. That makes sense, right? Yeah, that makes sense, right? 1,000, you can divide by 1,000 times, and then you will got 1 cubic centimeter of water should weigh 1 gram. Okay, so this is how the people define. They also people define 1,000 cubic centimeter is equal to 1 liter, and this is where the liter come from. Okay, 1,000 cubic centimeter people also call cc. Okay, so that's why if you're motorcycle race or the racing car, they talk about a 100 cc, 250 cc, and generally it talk about the volume of the gasoline, how much the gasoline they are going to use. So generally they talk about that parts. Okay. Oh wait, this is talk about engine size. The talk about size of the engine. It's not talk about the how much gasoline. You talk about size of the engine. Okay, so the cc means cubic centimeter. Okay, yeah. So this is where the liter coming from. Liter is 1,000 cubic centimeter. Okay, so 1 cubic centimeter, that's gonna be equal to what? 1 liter equal to 1,000 cubic centimeter. So 1,000 1 cubic centimeter should be equal to 1 milliliter, because milli is 1,000th, right? In other words, 1 liter, if you divide by 1,000, it should be equal to 1 milliliter. Okay, yeah. So, yeah, the milli actually it just means 1,000th. Okay, so that's why 1 liter, 1,000. So the meaning, that's why, okay, the definition. 1 liter equal to 1,000 cubic centimeter. And 1 milliliter is equal to 1 cubic centimeter. So those are interchangeable. Okay, 1 milliliter equal to 1 cubic centimeter. Those are interchangeable. Okay, yeah, but the point is why people using the two different units represent the same volume. That's because sometimes we'll measure the big, sometimes we measure the solids. For the solids, generally you can measure the Y height and the length. But for the liquid, how can you measure? You cannot measure the Y height. So liquid, we're using instead of cubic centimeter. Okay, so technically, cubic centimeter is for solids, milliliter for the liquid. Okay. Okay, so here is the some of the idea. Okay, where we talk about how to measure things, and we know the units, and we collected the number plus the units, and generally those are what we call the data. And so here is a set of the data, and when you read those data, then you have some of the idea about the things. Okay, so this is the weather report. Most of people are not very recognize this. But if you are reading the report, we have a temperature, those are in the Fahrenheit. We have a rainfall, we talk about how much rain we'll have on the ground. Okay. So we figure accumulate how much the water we can. Okay. So this is the average of the wind speeds. Okay. Yeah. And this is the relative humidity. Okay, you can add on the top from the whole class. But just so you know, you don't have any idea what is your human being, what is the comfortable percentage of the humidity. So what kind of, in other words, the relative humidity, in what kind of 80%, 85%, 75%, what does that mean? You don't have any idea. 5 or something. So comfortable humidity release is about like 45 to 65%. Okay, so 75, 85 is already too dry. Although it's too moisture, it's already too moisture. Okay. Unfortunately, you know, my hometown is by the river. It's really moisture. It's really hot. If you're living or if you visit the Louisiana, you will feel it. Okay, really moisture and hot. So in the summertime, it's really bad. Okay, even the temperature is not high, but I can feel my skin is very. I mean, it just cannot evaporate. The sweat cannot evaporate because the moisture in the environment is really high. It prevents our body to evaporate the sweat. Okay, so here I'm not going to talk about those things. I would like to talk about something like a derived unit and also some of the important concept like a unit conversion. Okay, yeah. Then we probably can, if we have a time, we will do some practice. If we don't have a time, we will do some practice next class. Okay, yeah. So the next concept we're going to talk about is the derived unit. So the derived unit generally is talking about the units that's coming from the basic units. The majorly that we're talking about is the density. What? Okay, so basically, most of the cases, we're already talking about a volume. Volume is one of the derived unit because when we write the unit, is meter time meter time meter. So that's a cubic meter. Okay, cubic meter. So that is the derived unit. So this unit is derived unit. And another concept is a density. And density, generally by definition, is talking about the mass over volume. Okay, the mass over volume. If you have a mass and you divide it by the volume of something, then that's going to be the density of the the density of the sum of the materials. Okay, and generally different material will have the different density. Okay, so we can also talk about we normalize this situation, but generally you don't have to worry about the density is a mass over volume, and the density is the property that can characterize a certain material, right? If we have a copper, and you know copper, the density is heavier. Aluminum is very light, right? Or some other materials are very heavy. So the density is the definition by this. And if you're looking at the unit, a lot of people don't know unit is important because unit can help you to understand, how we do the calculation. The unit for the density is kilogram over meter square. Kilogram over meter square. Or when people also using kilogram over cubic centimeter. Okay, so kilogram over cubic centimeter, I think this is a more common. This is more common than the kilogram over the cubic meter. So generally, this unit is for solid because it's pretty easy to measure those two. And if you're doing the liquid, then that's gonna be kilogram per liter. Okay, kilogram per liter. Or you can using the unit for gram per milliliter. Okay, those are also the units. Generally, those are units for liquid. Okay, kilogram per liter or gram per milliliter. Those both are for the liquids. And just to let you know, the interesting is 1 kilogram per liter, 1 kilogram per liter actually is equal to 1 gram per milliliter. And then you may ask why. We can just do the easy conversion between over here. So 1 kilogram per liter, and we know kilo means what? Kilo means 1,000, right? So 1 kilogram equal to how many grams? 1,000 grams. So this is 1,000 grams. Okay, so liter and milliliter. 1 liter equal to how many milliliter? 1 liter equal to 1,000 milliliter. Okay, 1 liter equal to 1,000 milliliter. So 1 liter equal to 1,000 milliliter. And you can see 1,000 grams, 1,000 canceled. Now the leftover unit is just gram over milliliter. So that's why 1 kilogram per liter actually is equal to 1 gram per milliliter. Those are the same units. Okay, we're talking about generally the same. If you're using those two units, the number given should be the same. Okay, 1 gram per liter, 1 kilogram per liter equal to 1 gram per milliliter. Okay, so generally those are the two the units for the density. The unit for the density. Okay, so this is a derived unit. Then we talk about the next part. I would like to focus on the unit conversion. Although we already talked about this, but it's better to do more, especially the conversion is most important part. Okay, the most important part, unit conversion. Okay, so let's see. Again, we know 1 inch is equal to 2.54 centimeter. Okay, so now we have if we have a 2.2 inch, then how many centimeter is equal? How do we set up this equation? 2.2 inch, and we try to figure out how many centimeter. Is that right? Okay, yeah. So you can write 2.2 inch, and then you're going to time a conversion factor. And the most important thing is, okay, different people doing the different way, but this is a very common way that we're doing, okay? Since we have the inch over there, so you're gonna cancel the inch, put the inch in the bottom, and the centimeter on the top. So if you're looking at here, before the centimeter is 2.54, and before the inch is 1. So this is how we set up. Now you know the inch and the inch is canceled. Now the answer is just 2.2 times 2.54 divided by 1. Okay, the left unit is the unit over here. Okay, so if you're doing this, you got a 2.2 times 2.54, and you got this number. And let's go in deeper. So now, do you know, should we write a 5 point? Just let you know, we shouldn't write 5.588, okay? Because the given number is only two given number. So you should keep a 2 given number.
6.
So the answer should be 5.6 instead of that much number. Okay, so you just need to, based on the given number, you write this is a 5.6. Okay, so let's do some practice. I have 3.332 centimeter. Okay, how many inches it is? Please go ahead to calculate. 3.32 centimeter. We're going to convert that to inch. How to set up this?
1.31. Divide by 0.54. Then meter goes on the bottom.
Okay, yeah. Let's just wait out the people to, okay, then make sure you got an answer and make sure you got the correct number. How many number you gonna keep?
2. 3.
3. The given number is 3.32, so you're gonna have 3 numbers to keep, okay? So 3.32. You time the conversion, which is 2.54 centimeter equal to 1 inch. So now centimeter and centimeter canceled. 3.32 divided by time 1 divided by 2.54. 1.3 and 1. 1.31. Okay, 1.31. Okay, 1.31. So then then this is just a single conversion. Then let's talk about the volume. Okay, volume is the most complicated. So let's talk about area first. Area, and this area is, for example, we have like a 1 meter. We have a 1 meter by 1 meter of the plate, okay? And the area for this is just a 1 meter times 1 meter. And we know this is a 1 meter square. Make sense, right? 1 meter square. And how can we convert this 1 meter square to how many numbers of the centimeter square? Okay, think about how do we convert that to centimeter square? This is a very important when you do the structure construction. Okay. Then you need to know, okay, what is centimeter? What is the relationship between meter and centimeter? One meter equal to 100 centimeter, or you can write 1 centimeter equal to 0.01 meter. Those are the same conversion. It's just using the different, start with different units. Okay. Then how do we convert that? About it, and you talk with your partner. A lot of people got confused and got it wrong on this part. The important thing is you're going to convert each of this instead of, so just to let you know, 1 meter square is not equal to 100 meters square. This is not equal. Okay, because you need to do the conversion, the calculation, because 1 meter equal to 100 centimeter. So this one should be 100 centimeter times 100 centimeter. And then you multiply together, you see? Say 100 times 100, which is 10,000. Do we have a 10,000 centimeter square? That makes sense, right? So this is a conversion. You're gonna convert each of the units instead of just convert doing this. Are you clear? Okay, so let's go do one more, okay? Now we have a unit. We have let's see, 2.5 meter by 3.0 meter of this object. How many centimeter square for this area? Okay. We have 2.5 meter by 3.0 meter of this object. And then what is the area in cubic centimeter? Go ahead, work on this.
Is that the multiplication sign or the sign? Or by the square of the square? Oh, okay.
This one not.
Oh.
Okay, so let's just review this one and then we're done, okay? So here, what are you gonna do? First, the unit is in asking for centimeter square, so you need to convert everything to centimeter instead of meter, okay? So first, you need to know, okay, 2.5 meter equal to how many centimeter? And since we already write over here, 1 meter equal to 100 centimeter, then how do we convert? Again, this is conversion factor. You time 1 meter equal to 100 centimeter. So 1 meter should be in the bottom because this is meter over here. 100 centimeter on the top. So 1 meter canceled. And then it generally is 2.5 times 100 centimeter. So you got 250 centimeter. This is the same thing. Your time 100 centimeter over 1 meter. So the meter cancel the 3.0 centimeter times 100. So you got a 300 centimeter. And then your time together. So 250 centimeter times 330 centimeter. And then you got a 75000 centimeter square. Right? So this is how we do. So please do not just convert directly with those numbers because we have a square here. You need to count the square over there. Okay, gonna count the unit for each of this and then time together. Okay, so this is what we do. I will assign some of the homework assignments over the weekend. Okay, so I will send an email to remind everyone about this. It will due on end of the Sunday. Okay, yeah, but won't too much. It's just the topic that we talked today. Okay, yeah. All right. So see you next class, and please give me the people time. You have them.
So only if we have questions.
Or is the way that you can. Want to.
So the one that's online,
I will, yeah, I will. Yeah, I will. Will assign it online.
okay. Okay, next week.